Our first presenter today will be from MULTIMATIC. Mr. Murray White is going to take you on his journey from skeptic to adopter. Murray, stage is yours.
So I look after vehicle development activities here, physical vehicle development. In the past, all of my career has been ride and handling development, and the last 25, 26 years of that has been here at MULTIMATIC. So I was around for the beginning of simulation, and we've seen it develop and come along, and I'll just take you through a bit of the journey that we've had at MULTIMATIC over recent years, where we've kind of started, where we've got to, and hopefully where we think it's going to end up in the fairly near future. So MULTIMATIC, you've probably seen all of our stuff around the building. You've been wandering around. We make high volume products, we make low volume products, and we build low volume niche vehicles for people. That basically sums up the overview of the company. Suspension, structural products, and mechanism products are our bread and butter. In the simulator world, it has applied mostly to our engineering projects and the support of our own portfolio products in the suspension realm. So control arms, dampers, and other suspension systems we do. The engineering side of the business, which I work for, we are responsible for engineering the high volume products, everything from hinges, control arms, and full vehicle design. We are also available for third-party engineering contracts, so we do a lot of exclusive vehicle development programs for people. They just need help development, whether that involves simulation or goes straight to physical development, depends on what the needs are. So we basically run the full gamut of vehicle development, vehicle engineering, vehicle simulation stuff with a strong bias towards the vehicle dynamics side of things. So this is our sort of simulator timeline. We'll come back to this, a variation of this slide in a while. 2011, we bought our first simulator, and it was installed in our technical center in Toronto. That was a Ansible platform, and back in those distant days, we were mostly involved with race car tuning on it, but we'll talk a little bit more about what we've done through the years on the different simulators we have. 2019, we procured another version of the same simulator and installed it at our UK facility in Thetford in England, at the European Technical Centre. Continue to work with that one. Then 2021, this facility opened. It should have opened earlier, but COVID got in the way. So by the time that was all done and dusted, this facility here that you've been walking around with, the DIM 250, opened in 2021. So that's kind of, we've been involved with driver-in-the-loop simulators for quite a long time, and we've learned quite a lot along the way about what you can and can't do with them so far. So we have what we call the MISA, MULTIMATIC Integrated Systems Analysis approach to all our engineering projects, whether it's a small hinge redesign or a full vehicle program. Basically, it's an overview of applying the right technologies in the right order at the right time to achieve the optimum results with the minimum timeline. So increasingly, the driving simulators have become a bigger and bigger part of this process, and we use them more and more on an increasing range of projects. I mean, the pure vehicle dynamics development projects, obviously, a simulator is a very useful tool. But we've been beginning to expand them into some of the control arm business we do, some of the other suspension parts, twist beam developments, that kind of thing, actually driving different designs in the simulator to look at the performance of component level optimization, how the parts we make are going to affect vehicle performance. So it's becoming a more and more integral part of a bigger and bigger chunk of our business. So this is a sort of modification of that timeline slide. The more astute amongst you will notice there's not much going on the left-hand side of the slide. So in terms of the progression of capabilities, early in our driving simulator use, it was very motorsports focused. I mean, they were already well established in the motorsports arena. All the Formula One teams had been using them for a while, and it was gradually filtering down into the lower levels of motorsport, including us. We did lots and lots of very successful use for motorsports engineering customers, chassis development, aero development, and with consistent improvement in correlation to on-track performance as we got more and more knowledgeable about how to use them. In terms of road car use, the Z28 Camaro with our spool valve dampers on, the first production implementation of the spool valve damper, that was really the first road car that I was involved in that we tried to do some work on the driving simulator. And so we had decent success with Nürburgring and VIR in particular, Virginia International Raceway circuit tuning activities. Limit handling performance, lane changes and things showed pretty good correlation. Lap time correlation was good. Actually doing some damper development and evaluating the handling effects of the vehicle were quite good on the racetrack. And attempts at ride development, however, I've put here, you can see they were largely unsuccessful. I think it's probably fair to say they were completely unsuccessful. So the bits that transferred across from motorsports in terms of track performance were unsurprisingly quite successful. The other half of the equation, which is equally important for road-going vehicles, was far, far less successful back then, that we found anyway. So when we get to the mid-teens, 2015, 2016, 2014, we were heavily involved in the design and development of the Ford GT at that time. We evolved the track-based development use of the simulator to include more complex systems. The GT has a DRS system, state-based traction control on the motorsport side. The GT also has a active aero system. So it's got an air brake, which is highly influential on the way the car behaves. So we integrated more and more of the aero systems and electronic chassis control systems into our road car models and their influence on the handling and the ability to evaluate lots and lots of iterations of chassis controls, algorithms and things. We had Bosch working with us on the simulator with hardware in the loop, Bosch controllers in our GT model to actually develop some of the chassis controls, ESC and ABS work on the simulator, which was quite successful. Again, still primarily a limit handling tool, not much capability in the ride side of things. And that was a limitation of the simulators we had at the time. So now we move up to 2018, 2019, and the pictures get a bit more populated, and that reflects the very, very quick progress that we were able to make when we started working with the DIM 250s. My first experience was the AMG 1, which is the red and black prototype thing there. We were heavily involved in the design and development of that car as well. AMG had a DIM 250 a long time before we did, and they had an actual AMG cockpit tub on their DIM with more hardware in the loop than I've ever seen anyone ever do. It had the iBooster, electronic brake booster. It had brake calipers. It had the ABS unit. It had the ESC unit. It had pretty much everything. Everything that could be hardware in the loop was. The car is incredibly complex. It's got 2 ride heights for road and track. It's got active aerodynamics. It's got active torque vectoring, which is driver selectable, the amount of torque vectoring. It's a hybrid car, so it's got variable regeneration, depending on the battery state. So it's just an incredibly complex animal. And we were able to do an awful lot of work on the simulator that would have taken many, many track days and many, many sets of tires to do on track as we went along. And we didn't only use it up front. Every time we went to the track, the correlation got better. So we kept using the simulator throughout that project. And that was my first experience of the DIM. And that's when, you mentioned the inflection point. That was when the kind of light bulb went on for me that, wow, there's a lot more you can do with these machines than we've been able to do up to now as the technology of the simulators themselves increases. So around the same time, and a bit earlier, our damper business, we were getting heavily involved with GM on their off-road truck side of their lineups. So we were trying to use the simulator for some off-road development, which is still proving challenging, but I'll talk a bit more about that later. We did, however, begin to explore, as part of an R&D project, use of the DIM for ride evaluation. We make passive dampers, we make position-sensitive dampers, we make adaptive dampers, and we make active suspension, full active suspension systems, which with the adaptive and the active systems, you can play with the hardware and you can play with the algorithm tuning, the strategies and the calibrations, and it's highly interactive what you do. And being able to do that on the simulator has been a huge, huge bonus. But in order to be any use at all on that, we actually had to be able to start evaluating ride quality on the simulator, which was a bit of a journey in itself. So several elements were involved in making that happen. The first three, to you guys, who I'm guessing are mostly simulator heavy or simulation heavy in your jobs, will be obvious. The vehicle model, road model, and the platform queuing. I'm not an expert on all those. We have people around from our organization who are, if you have any questions on that later. I'm just trying to preempt any questions that I won't be able to answer. we have people who probably can if you have questions on how we progress those things to make it more successful. The last two was where I think the practical experience of vehicle driving came in and unlocked things significantly. The cockpit layout, sitting in the cockpit, the windshield view, the ergonomics, the seat you're sitting on and the steering wheel you're holding are all massively influential on your perception of ride quality and all the aspects that get binned under the ride kind of banner. So we have a configurable cockpit we designed, which I'll show a bit more about in a while. The next thing was well-known ride evaluation environments. So reproducing our own preferred ride routes in the simulator, so scanning them and rendering them so they look like the ride routes we drive on and they feel like the ride routes we drive on, were absolutely paramount we felt in making it useful to us, and that proved to be the case. We have a number of road routes we use around here when we're doing development. We have a number in England. We have a number in all our facilities around the world, and we scan our preferred ride routes that we know how cars need to behave on to be market acceptable and customer accepted, and we virtually develop cars on those known ride surfaces because we know how the model needs to feel for the car to feel acceptable to customers because we're so familiar with those surfaces. Right, so the modular cockpit is basically we can change the shape of the cockpit, the look out through the windshield. We can change the shape of the A-pillars and where the header rail is and the view across the dashboard to simulate the car we're trying to develop. It's also lighter than many of this one is the one on the right. That's our configurable one. It weighs about 200 kilograms, which is considerably lighter than many of the full body in whites that people use. I think I don't know for sure. You imagine it has to have some advantages in terms of frequency response. The lighter the buck is, it gives the platform an easier time achieving the higher frequency responses that are very important for ride development. So basically the scanning of our own ride surfaces, lots of motion queuing development, lots of refinement of the vehicle models themselves and the road models themselves, and the eternal simulation holy grail of the tire to road interface, which we're going to have some presentations on later, which will be interesting. We got to the point where we started, if we go back to this slide, the Mercedes C200. We have an R&D project, C200 in the UK. It's got electronically adjustable dampers on. We set up the car with 5 different modes in the electronic damper memory, and we tuned them to have 5 very distinct characteristics, which were easily discernible. And just driving the car blind, you could say, okay, yep, that's mode 2, yeah, that's mode 3, that's mode 4. When we started trying to do the ride development on the DIM, we'd model that car, have the same modes in the damper controller, and you'd be driving down the same road and say, okay, let's switch to mode 2. You go, okay, did you change it? And you'd get over the earphones, yep, we changed it. It's like, are you sure? Yep, we're sure. And we really couldn't tell. So that's a problem, because in the car, the real car with the same changes, massively different behavior. So we embarked on this whole development process, which has already been, we talked about a little bit about here, the model and the road and the platform queuing, till we could accurately replicate the differences between modes, tell the modes blind, and at that point you think, okay, there's something here. We can now begin to do ride development on the DIM. So when I put this presentation together, I didn't realize we were actually going to run this exact thing in the DIM today. So many of you may already have seen this, but this is an iPhone video looking out the windshield of our DIM on one of our many UK roads. That's why we're driving on the left. But we've scanned many of them. We know how cars need to behave on this road in real life. So we tune vehicles to feel like it on the DIM. And we've now got pretty good success in having cars that we build to DIM-developed specifications driving in a quite similar manner. So here in Michigan, we use, again, a number of routes. It's kind of ironic that always happens. Our section of 696 that we know and love for mid-frequency ride performance. Anyone that tried to get here from east of here will have noticed that it's completely been dug up. So that's another of our ride surfaces disappeared. But we still have it in the DIM, and we'll still continue to use it. But now we just have to go a bit further east in through Royal Oak to get the same kind of choppiness content. We have this one. This is part of that same ride route. We modeled the on-ramp because it's very useful for real-world linear range handling evaluation. We have some special events model. This is a fairly serious railroad crossing that's out by 5 Mile west of Beck Road. That's kind of a special event we use for some of the off-road truck tuning in particular. And this is Gun Road up in, I guess, Auburn Hills or Lake Orion. I'm not sure where it is. Up near Bald Mountain, which is just a broken surface, kind of lots of primary ride input, which is fairly hard to find around here. It's broken surface, very easy to find around here. Roads with significant primary ride input are less so. So we've got that scanned for that specific purpose. So really that's where we've sort of had our little journey that we've been on, where we've got to. So we've already had pretty solid success. Oh, I should just talk about one. Sorry, I should go back and talk about one of these other cars because it's kind of an interesting story. The black car in the top right, that is Mark IV Ford GT, which is a track-only kind of final hurrah build for the Ford GT. We're building 60 of them. That car runs our ASV adaptive damper system, significant aero, slick tyres. It's a very, very serious car. It is going into production with damper curves and ASV calibrate. ASV is our adaptive spool valve. Damper curves and adaptive calibrations developed 100% on the DIM. We didn't trust it and just put them in the car and sell it. We evaluated 3 or 4 different options that were developed on the DIM in the vehicle with several racing drivers, and everybody chose their favorite, and we came to a consensus on which was the favorite, and that is the first car that certainly that we've ever done that will go to production, albeit only 60 cars, with 100% DIM-based damper system on it, which if you'd asked me that 5 years ago, I'd have said you'd never do it. Even on a car that's 100% track-based, which gives you the best chance of doing it, I wouldn't have had confidence that you could do that 5 years ago. But now, that's the reality of the situation. That car will be on sale with DIM-based, DIM-developed damper settings in it. Through that, I guess you'll have concluded we've already had pretty good success enhancing our ride capabilities on the DIM. In addition to, we already had pretty good success with the handling level stuff. Further enhancements, ongoing, critical to continuing the evolution of the process. Audible ride content, which is massively influential on impact harshness perception. You may have had a go in the VI Grades static simulator, and they're heavily involved in moving that part of the game along quite successfully. So that's in hand. Enveloping tyre models, everybody's working on those as well. It's the first layer of isolation between you and the road. So clearly massively influential on how the car rides and the higher frequency stuff. Secondary ride. So that's evolving and needs to. Will continue to do so. So in the off-road vehicle arena, you see the little video playing down the bottom. There are 2 issues there mainly that we found with replicating it on the DIM or any simulator. One is the deformable tire, deformable surface to tire interaction. That's still a developing technology, but it is a developing technology and people are working on it all the time. The second is how you manage the motion cueing when clearly the vehicle is moving in reality outside the physical capabilities of the platform itself. So that's something we're working on. We've had some success with it. It's really a case of understanding the offsets and what you can and can't do. That's where we're at. Anyway, other people may be further along in that game. Or probably simulators will just gain more and more motion. I mean, lateral and longitudinal motion is increasing all the time. VI Grade keep coming out with bigger and bigger DIMs, so maybe the vertical capability will also be better matched to this kind of vehicle, which is fairly niche, admittedly. So a year from now, all this stuff will have progressed further and we'll be able to use it even more. 5 years from now, who knows where we'll be. I mean, 0 prototypes is a lofty goal, but several of the big OEMs have announced that's where they're headed, so we better figure it out. So, all right, that's it.